Today, we're going to be talking about one of the many items behind me in this set. A set which, for some reason, some of you think isn't real? Even as I reach for the item in question, a physical item in the physical set that I physically sit in front of, a few of you will convince yourselves that this is all an elaborate compositing effort because, well, frankly, I don't know why. I mean, it should be obvious from my videos that After Effects is a program that I open accidentally, stare at in terror, and then feel guilty about never bothering to learn despite multiple New Year's resolutions. And yet, some of you think me and Captain Disillusion are the same person? How? We sound nothing... Anyway, I will now reach for the thing. That is a real dust spot, by the way. This is a Canon F1, a 35mm single lens reflex camera introduced in 1971. Single lens reflex, often shortened to SLR, means that the view through the viewfinder is through the same lens that exposes the film. This is done with the aid of a mirror, which redirects light from the lens onto a ground glass focusing screen to allow the shot to be composed exactly as it will be captured on film, eliminating the parallax error from a separate viewfinder and allowing you to preview the depth of field with a stopped-down lens. When the shutter is released, the mirror is swung up and out of the way, allowing the light from the lens to land on the film itself, after the shutter has opened, of course. I love this camera, though I haven't used it in quite some time, and we're going to talk a lot about analog photography as time goes on, but this particular video is about one fundamental aspect of how you use it. Its light meter. Now, quick side note, there were plenty of cameras with automatic exposure available to the consumer when this was released, like this Olympus Pen EES2, which you better believe we'll be talking about someday because it's got all sorts of weirdness. But the Canon F1 is entirely manual. And in fact, entirely mechanical. That's a large part of why I love it. It's built like a tank, weighing in at just shy of 850 grams, or nearly 2 pounds. That's without a lens or film, mind you. Lightness was never a priority. By the way, despite its uncanny resemblance to some sort of LCD screen, this thing is in fact nothing but a holder for the torn-off end of a box of film, to serve as a reminder of what you put in it. Interacting with this camera is so delightful. Everything is where it is because that's where it needed to be. All the controls are physically connected to the mechanisms they activate, which makes them delightfully chunky. You can see how turning the film advance lever cocks the shutter by moving the two halves of the shutter curtain in unison. And you can even hear the little clockwork mechanism that controls the shutter's timing at long exposures. Take a listen. Still, even with the constraints in place, Canon managed to make this brick of a camera decently ergonomic, for righties anyway. Your thumb, index finger, and middle fingers rest naturally on the film advance, shutter release, and front control, respectively. My personal favorite thing is that front control. Push the lever towards the lens and it closes the aperture so you can get a depth of field preview in the viewfinder. But turn it the other way and you can feel that you're winding something up. Well, I just love that. That's its self-timer. Oh, and that little lever on the bottom, that is used to lock the aperture preview in place and lift the mirror for vibration-free long exposures. This camera requires no batteries to function, and yet it can do pretty much anything you can reasonably expect a 35mm camera to do. Well, aside from autofocus and motorized film winding, I did say this was entirely manual. The F1 was designed to be incredibly modular though, and you could accessorize it with all sorts of things from motor drives to different viewfinders to bulk film backings. This one though is in its stock form. It has the standard everything. And while it does not need any batteries whatsoever to function, it does have a battery compartment on the bottom. In here lies a small coin battery which powers the light meter. What's a light meter? Well, it's not a questionable astronomical unit, it's instead an information display. Alright, quick crash course in basic photography. Almost every camera ever can control the amount of light that hits the film or image sensor in two ways. the lens aperture, and the shutter speed. Inside the lens is a multi-bladed diaphragm that can, to put it in rather basic terms, reduce the size of the lens's opening through constriction. Those are what the F numbers on a lens are, and the higher the number, the more constricted that opening becomes. Thus, the less light makes it through to the film or sensor. A side effect of this is that the depth of field, that's the range of depths that are in focus, becomes deeper the more constricted the lens becomes. That means that more of the image is in focus, much to the chagrin of bokeh fans, when a higher F number, and thus smaller aperture, is used. Note that for landscape photography and other scenarios where nothing is close to the camera, the depth of field becomes more or less irrelevant. The shutter speed, meanwhile, is, in still photography, the amount of time the shutter remains open. Leave it open for longer and you can collect more light. Hardly open it at all and you collect less of it. The trade-off here is that long exposures require very still scenery and probably a tripod, as any motion will be blurred. Shorter exposures, on the other hand, will freeze motion, but they require more light through a wider open aperture. Shutter speed is measured in fractions of a second, and this camera is capable of speeds from 1 second to 1/2000th of a second. B, short for bulb, will leave the shutter open as long as the shutter release is pressed. There's an inverse relationship between shutter speed and aperture. Higher F numbers allow less light through the lens, which means the shutter has to stay open longer to collect the same amount of light. And if a shorter shutter speed is desired, the aperture has to open wider to allow more light through the lens. In order for the exposure to be correct, the aperture and shutter speed must be an appropriate combination for the amount of light available in the scene and the sensitivity of the film or sensor. However, once you know one combination that works, you can adjust the shutter or aperture up or down so long as you adjust the other setting appropriately in the opposite direction. The F numbers, by the way, are as weird as they seem to be because the number itself is a geometric ratio. But we want to have stops at each value that halves or doubles the amount of total light going through the lens in order to correspond to the available shutter speeds. We call those stops So now we've come to the metering bit. Every film stock has a certain sensitivity to light, known as its film speed. The term speed comes from the fact that exposure time will vary based upon sensitivity, all else being equal. We now call that the ISO, though back when this camera was made, it was called the ASA, the initialism for the American Standards Association, now known as ANSI. See, back then, Germany was doing its own thing with a logarithmic system they called DIN, the acronym for their standards organization, incidentally. But in 1974, the International Standards Organization said, you know, we're just going to mash the ASA and the DIN together, and now that's the ISO. But nobody ever remembers the DIN half of it. The ISO 100 should really be 100/21 degrees. So in a weird way, we're still using ASA, but calling it ISO. At least outside of Germany. Anyway, nope, one more tangent. ISO. I say the 3 letters. Why? Because ISO and ISO are so close to each other that I don't think it makes sense to force the acronym. Does it matter? Of course not. It's just like my opinion, but I will at least grant that it's less atrocious than calling this NHTSA, which they're trying real hard to make a thing in case you hadn't noticed. And I regret to inform you that it's working. Anyway, modern digital cameras have an ISO setting because you can change the sensitivity of the image sensor. But back when we were using good old emulsions of silver halides on a clear plastic backing, you'd be stuck with whatever the sensitivity was of the film you bought. Of course, there are many kinds of films from many manufacturers, and the film speed is itself something of a trade-off. More sensitive films are usually grainier, so you'd want to pick the appropriate film for your situation. But now, well, how are you supposed to know what shutter speed and aperture setting you should use? You have to get the exposure correct if you want the resulting image to have decent dynamic range. Otherwise, it will be blown out from overexposure, or a dark mess without any detail. Well, there are some general rules of thumb you can use in certain situations. For example, on a clear sunny day, you can use the sunny 16 rule. Set the aperture to 16 and the shutter speed to the value that most closely matches the film speed. So if your ISO is 100, 1/100th of a second, or the closest available setting. On this camera it would be 125. This works because a doubling in film speed equals 1 stop in exposure. It requires half as much light. And at f16, the correct shutter speeds happen to match the film speed numerically. If you need a faster shutter speed for a given shot, just open up the aperture an equal number of stops that you increase the shutter speed to compensate. But newsflash, not every photograph is taken outdoors on a sunny day. Wouldn't it be nice to have something that can tell you the correct exposure for any given scenario? Enter the light meter. These devices are able to, with the aid of some sort of light sensor, provide the user with an appropriate exposure value. These devices were originally handheld and were fairly crude. Generally, they just have a needle-type readout which would point to the appropriate aperture value for a given film and shutter speed. To use them, you'd bring them to your subject and point them at something which was close to a middle gray in terms of brightness. Then you'd set your camera up appropriately. You can still buy handheld light meters today, though they've been digitified, of course, but before long they were integrated into camera bodies themselves. And that's why this otherwise mechanical camera has a battery compartment. Now, keep in mind that this camera was originally released in 1971, though this example is a later revision. Its light meter will be limited to the same sort of analog tech that was found in the handheld meters of the time. But, and this is why I wanted to make this video, it was done in an extremely clever way that not only simplified its operation to the user, but allowed for more flexible use of the camera. The meter appears as a small display to the right of the image in the viewfinder. Right now the camera doesn't have a lens on it, but watch what happens when I put one on. The small circle moved upwards. That circle is mechanically linked to this little piece here. You can see that as I move it with my finger, the ring moves up and down. This engages with a small peg on the lens itself. Once installed on the camera, moving the aperture ring on the lens causes that ring to move. Now, in addition to the ring, there's a small horizontal line. Right now, it's sitting in the bottom red area. This is actually a needle that will move depending on how much light the camera sees. And this is where the battery comes into play. You may have noticed this power switch. All that does is turn on the light meter. That little blue mark in the meter's display is used as a battery level check. You can see there's a little sticker here reminding you that to check the battery level, the shutter speed should be set to 2000 and the ASA to 100. Then, when you move the switch to the check position, the needle should jump up to the blue mark, and so long as it does, the battery's okay. If it doesn't make it to the blue mark, well, it's flat, and if it overshoots it, we'll get to that. When the meter is turned on, you can see the needle move with the amount of light that hits the camera. The brighter the image, the higher it goes. But where exactly is it measuring? You probably noticed the darker portion of the viewfinder towards the center. That is the sensitive area of the light meter. With a lens on, you can see that it's only what's in this area that affects the needle's behavior. But how is that possible? Where is the actual sensor? Surely we didn't have transparent light sensors in 1971. Well, maybe we did, but that's not what's going on here. Again, it's extremely clever. One of the many things you could customize on this camera is the focusing screen. To remove it, you simply remove the viewfinder by pressing in these little lock buttons and sliding it towards the rear. And there's the focusing screen. Kinda trippy, huh? That's what we were looking at in the viewfinder, but now we're looking down at it. In fact, all the viewfinder is a prism, a roof pentaprism to be precise, there to redirect your view from the eyepiece downward and flip the image horizontally. This creates the distinctive hump you see above the lens on all SLRs to this day, though I must say I much prefer these sharp lines, which don't hide the nature of the thing, to the blobular designs of today. Anyway, this is the focusing screen, and it too is removable. Before I even remove it though, something about it seems weird. That darker region appears to be floating. Now, this is obvious in person thanks to stereoscopic vision, but it might not come across well on camera. I'll try my best though. At the very least, you can see that the circular focusing aids in the center are actually separate from that darker region. If I pop the focusing screen out, you'll get a clue as to why. See that little window there? look through it. Weird. That dark region is actually a semi-transparent mirror that is floating in the middle of the glass somehow. I really want to see how these were manufactured. But anyway, it redirects some of the light coming up through the focusing screen out this little window. And if we look from the front, you'll see what lies behind it. The light sensor. From the looks of it, it seems to be a simple light-dependent resistor, or LDR, though it's obviously a little fancier than the one in your garden variety nightlight. The amount of light that falls on this will, thanks to the battery and the simple electronics it powers, determine where the needle in the meter lands. So, in the end, that rectangle is simply the dark region left by a semi-transparent mirror embedded in the glass of the focusing screen at a 45-degree angle so it can redirect a portion of the light onto the sensor. That's what I call neat. Now that we know where the meter measures, how it works, and what it does, how does one use it? You may very well have figured it out by now. This variety of meter is called a match needle meter, and that ring, well, it's your target. To use this camera's light meter, you first point the camera so that something in the scene that's not too bright or too dark is within that metering region. Light meters in cameras are generally calibrated to a middle gray value, and this is no exception. Now, simply turn the aperture ring on the lens until the ring surrounds the needle. You are now set to the correct exposure setting, so you can recompose your shot however you like, hit the shutter release, and you're done. One exposure down, 23, maybe 35 more to go. But what if that combination isn't what I want? Maybe I have to stop the lens way down in order to match the needle's position and expose correctly. I'll lose my sweet, sweet bokeh. Well, nothing a little after-the-fact AI-powered image processing can't fit. I mean, that's no problem at all. Simply adjust the shutter speed so that it's faster. Aha! The needle moved. Here's where the other part of this genius system comes in. The actual sensitivity of the light meter itself is affected by both the selected shutter speed and also the film speed. Perhaps you noticed this little insert in the shutter speed dial. Rotate the dial while pulling up on it, and you can change the film speed setting, which will make the meter more or less sensitive. And the shutter speed alone has the same effect. Increasing shutter speed causes the needle to fall down, which means you need to open the lens up to match. Now, you could have worked this out in your head by just counting the stops to, say, f2, and then increasing the shutter speed by the same number of stops. But having the meter work differently depending on the shutter speed offers a sort of sanity check. It also demonstrates the relationship between shutter speed and aperture beautifully. Each stop you move in shutter speed requires 2 clicks of the aperture ring to compensate. 2 clicks because this lens has detents at half stops. Most elegantly though, the matching nature allows for shutter priority or aperture priority exposure. Rather than just point the camera at the scene and find a combo that works, you can fix one of those variables ahead of time and adjust the other as needed. Say you want a stopped-down aperture of f16 for a deep depth of field. Well, set the lens to f16 and keep changing the shutter speed until the needle gets in that ring. Or perhaps you need a fast shutter speed to freeze motion in action shots. Simply set the shutter speed to 1000 and move the aperture ring until the ring surrounds the needle. Easy! This metering arrangement is not only intuitive, but it's flexible and also just a great teaching aid to those learning photography. You see hints of it in modern interfaces, and then of course there's even more powerful stuff these days like histograms and whatnot, but there's just something about the way this works that is beautifully elegant to me. Should we talk about the weirdness though? Let's talk about the weirdness. First, there's a limit to its range of operation. Watch what happens as I approach a shutter speed of 1 second. At a quarter of a second, the meter turns red. It doesn't exactly stop working, but it behaves erratically. If I increase the film speed to 1600, the meter goes red at a 30th of a second. And here, at really slow shutter speeds, the needle just stops changing at all, even when it should. Now the meter is definitely not working right. What's going on here is that the meter is a lot simpler than you may imagine. Changing the shutter speed setting simply changes how sensitive the meter becomes. As you slow the shutter, you need to close the aperture down in equivalent stops for the same exposure. The meter needs to move the needle higher to indicate that, which means the needle becomes more sensitive to given amounts of light. But the same thing needs to happen when you increase the film speed. If you doubled the film speed, you'd need half as much light for the same exposure, so the needle needs to move one stop higher. Doubling the film speed demands that the sensitivity of the meter change exactly as if the shutter speed were cut in half. And the simplest way to do this? Just shift everything over. The needle will indicate the same apertures for a doubled film speed as it would for a halved shutter speed. So, if you can shift those sensitivities around, you can adjust the meter for different film speeds. That's exactly what changing the film speed setting does. In fact, that's literally what it does because we're dealing with a mechanical contraption. Adjusting the film speed essentially relocates the different sensitivities of the light meter independently of the camera's shutter mechanism. There are more meter sensitivities than there are shutter speeds on the high end, but there aren't on the low end. The meter just isn't sensitive enough to tell you how to expose a low light shot. So, as the film speed increases, the lowest speed settings become locked out because that sensitivity is now assigned to a higher shutter speed. Each doubling of film speed locks out the next lowest shutter speed. In the end, the meter is just an analog device that's been finely calibrated to move the needle logarithmically. Each doubling of light landing on the sensor makes it move the same distance upward. I imagine each sensitivity level is just adding a different resistor to the mix. Which brings us to the next bit of weirdness: batteries. When this camera was made, we were still manufacturing mercury batteries because, we hadn't yet come to grips with the fact that the garbage can isn't a magic receptacle that just makes things harmlessly disappear forever. The trouble is, mercury batteries produced 1.35 volts. That's a weird voltage these days. While you can buy a replacement battery that fits perfectly in the battery compartment, it will likely be a 1.5 volt alkaline battery. You might not think that's enough to matter, but remember, this is an all-analog system which is calibrated to behave logarithmically. The voltage matters a lot, and those batteries simply do not work. They push the needle way too high, and it will never give you an accurate reading. If you do a battery check with one of these alkaline batteries, the needle will end up all the way up here. Trust me, I know. That same sort of error makes its way into every metering scenario. However, there is a solution. Zinc air batteries, which produce electricity through reacting with oxygen in the air, are commonly available. They're pretty neat all on their own, featuring a surprisingly large energy density due to the nature of the reaction, but they have a time-limited life because you can't stop the reaction once you remove the adhesive pull tab. However, for some applications, like hearing aids, this drawback is more than made up for by their energy density. And most importantly, the voltage they produce is close enough to 1.35 that they can be used in cameras like these. Now, you can buy a Zinc Air drop-in replacement online for about $5, but you'll be quickly annoyed with that option since, as I said, they have a built-in time limit. So, pro tip, get yourself some 675 hearing aid batteries. They're about the same thickness as the PX625 battery this camera is designed to take, and although they're not the right diameter, a simple loop of wire insulation will center it well enough. You may need to bend the camera's negative tab up slightly, but this simple modification allows you to use batteries you can buy at Walmart for about $1 a piece. And as a happy accident, the battery compartment cover has a couple of holes allowing air in, but they're small enough that in my experience a battery will last a good couple of months before it's dead. You might also have asked, where is the meter's display, and how is it lit? You can see it in the viewfinder quite clearly, but when you remove the viewfinder, you find just a blank hole where it was. Well, the meter is actually right here. It's tiny, and this piece of translucent plastic up here is what illuminates it. Old cameras are filled with all these clever, intricate mechanisms. I mean, think about the linkage connecting the shutter speed dial to the tiny little indicator in the meter. It's amazing. Oh, and you could purchase a different viewfinder which had its own battery and light source for the meter, but this was never really super useful since the meter doesn't work in low light anyway. For outdoor photography, that little window works surprisingly well. Speaking of, did you notice the off position of the meter is also marked flash? How does that work? Well, it doesn't. Remember, There's no automatic anything, and when this camera was made, you'd use a chart on your flash itself to set exposure correctly based on film speed and distance to the subject. Oh, and that's why the shutter speed 60 is marked in orange. That's the flash synchronization speed of this camera, or the fastest shutter speed where the entire shutter is open at once and thus suitable for use with the flash. Since this camera's shutter curtain moves horizontally, its shutter is pretty slow, and you can see even with a smartphone's slow-mo that any speed above 60 doesn't expose the film all at once. This can actually create distortion in certain scenarios, so in a funny way, this old camera has a rolling shutter. Go figure. The shutter mechanism alone is just incredibly intricate and also fascinating. I mean, the curtains themselves are made of titanium, and they're flexible. They roll up into these little compartments here, and move as one unit when you cock the shutter and advance the film. You can see the seam right here. But with the press of just one button, they move apart and come back together with precise control in a fraction of a second. All done entirely mechanically. Amazing! This little thing here is the old style flash hookup, though up here in the film rewinder is an older style of hot shoe. These little contacts here, along with those inside the plug, are bridged right when the shutter is entirely open, signaling an electronic flash to flash. But anyway, now we're getting well into the nitty-gritty, which we'll save for later. I hope you enjoyed this look into the old-fashioned light metering systems of yesteryear. While it's fundamentally very simple, a lot of ingenuity was built in to make it usable, intuitive, and flexible. But we've just scratched the surface on how this camera takes pictures. What about the film itself? How does that store an image? And what about film development? How do film negatives become printed photographs? Oh, don't worry, there's a lot more to explore with analog photography, and before long, we'll get there. See you in the dark room. Single lens reflex also already screwed it up. And it's great because I have to retake the other line too. I don't like how I said fundamental. I forgot I need to open that. The more constricted that opening becomes, thus the less light. That means that more of the image is in focus at once, much to the chagrin of bokeh fans. When a higher f number, oh dang it, yeah, I forgot the delivery. So we'll move that over there. How about that? But nobody ever did. It's going so well. But in 1974, the International Standards Association said, organization. Dang it.